Today we're going to look at the last way of factoring a quadratic, and it will be completing the square. So basically what completing the square does is exactly what its name says. You complete a square. And the piece you complete will be where I just put the question mark. Now, when do we use it? We only use it if the first two methods did not work. Reason being, this is probably one of the tougher methods. The way you do it, or your steps for doing this, is you want to set up an equation. So see, it's already different than your greatest common factor, and slide divide bottoms up. Okay. So again, if you don't have an equation, you have to make one. You want to factor, so your x squared coefficient is 1. You're then going to divide your x term by 2. Once you get that value, you're going to square it. That value you're then going to add to the constant side. Once you've done that, you'll write your variable side as a single factor squared. And then last but not least, you'll move your constant to the side with your variable or your factor. So some examples of this be on page 18. All right, so again, first example, I have an expression. The expressions are no good here. Again, you have got to make this an equation if you don't have it as one. And again, to make something an equation, just set it equal to 0. First thing I want to do is I want to group my variables together. So the way I do that in this example is just add 38 to the left and right side. Next step I want to do is make sure my coefficient in front of my variable squared is 1. Again, if you don't see it, it's an understood one, so I'm good there. Next thing I want to do is divide my variable with a degree of 1. Divide that coefficient by 2. So 14 divided by 2 is equal to 7. I'm then going to square it. 49. Okay, so I have p squared plus 14p plus 49 equals 38. Well, because I added 49 to the left, I must also add 49 to the right. I then want to write everything that's on the left as a single factor, or what we call a perfect square trinomial. Now, a little secret to this: whatever you divide your linear term or your term with a degree of 1 by, whatever that result is after you divide by 2, that's always going to be your factor. So p plus 7, again, write it as a single factor squared, is equal to 87. Now we subtract and move our constant term back to the side with our variables. We have p plus 7 squared minus 87 equals 0. You can double check this really quick by FOILing or doing a box method. P squared plus 7p plus 7p plus 49 minus 87 equals 0. Combine like terms. Degree of 2, degree of 1, degree of 1. Constant, constant. P squared plus 14p minus 38 And this equation that you end up with should come back and be your original equation. So now I'm going to do an equation this time. However, I'm going to choose one where my coefficient is not 1. So regardless if you have an equation or an expression, we have to change it to an equation. And we got to wind up making it or grouping our variables together. And then once we group our variables together, we got to make sure our coefficient of our variable squared term is 1. So I see this in an equation already, so I don't have to do anything. My variables are already grouped, so I don't have to move anything around. Next thing I want to do is look at my coefficient. It's a 2. So to make this 2 a 1, I need to divide everything by 2. So 2a squared divided by 2 minus 8a divided by 2. Another way you can think about this is factoring a 2. And again, we only do this for the left-hand side. And then it becomes the same thing we just did. So 2a squared minus 4a equals -6. Divide your b term or your term with the degree of 1, divide it by 2. 4 divided by 2 is 2. We then want to square it. 2 times a squared minus 4a plus 4. Now be careful here, because I added 4, or what looks like is 4, to the left side. I would also add to the right side. But notice how it's in these parentheses, which this 2 is outside, which really goes to everything. So it's going to really be an 8. Okay, so I'm going to add 8 to both sides. Excuse me, a positive 2. Again, factor the trinomial we just made, which is a minus 2 squared equals 2. Again, I want to set my equation back equal to 0, and it becomes 2a minus 2 squared minus 2. And I can go back and double check this again. 2 times a squared minus 4a plus 4 minus 2. 2a squared minus 8a plus 8 minus 2. Squared term, linear term, constant, constant. Then combine my like terms. 2a squared minus 8a plus 6. Again, this was equal to 0. It doesn't look like this over here, but if I want to try and make it look like that, I see my variables are on the left, which is good. Now I need to move this 6 to the right. The way I do that is subtracting 6. I'm left with 2a squared minus 8a equals -6. And then if I can say that and that are the same, then my answer is correct.